doing?
I'm doing good. How are you?
Good, not too bad, thank you. Yeah, just unfortunately, just had a bit of a bereavement. Unfortunately, I've lost a family member. But
Sorry to
yeah,
hear this.
yeah, just trying to go through as best as I can. But yeah, not to worry. We are going to focus on going through some calculations on trig today, because that's one thing you said you haven't fully explored. How's your week been anyway, in terms of the practice? Have you been able to go through some more practice regarding past papers? Because we had a conversation on past paper practice. Is that something you've worked on this the last few days?
I actually did a past paper in lesson this week
Oh, good. How did that
as
go?
practice. It was a stats one.
Okay. And you're fairly strong with stats, so it's not your weakest module, really, is it?
Yeah, I just need to practice on it a bit, but I think pure and mechanics are the
Oh, the
most.
main, yeah, no, I absolutely understand. That's where you want the main focus to be. No problem. Okay, so without further ado, then it's gonna be a mixed bag of trig questions. Some asking you, there's gonna be some proofs. I know we don't like proofs, but throw in one or two just to make sure that if they're talking about proving by counter example, you're able to do that when it comes to these things on the trig side of things, because we didn't really. How were the questions on proof in your test, by the way? We didn't catch up on that.
She's not marked the test, so I can't look
Did you
back
have
at it. She
questions
said
on proofs?
yeah, we did. It was on a triangle.
Okay. Was that
It was like a
okay?
right
Was that not
angle
too bad, or
triangle.
did you find that okay?
I think everybody in the class found it a bit hard,
Oh, I
but
see.
I just have to get my test back to see if
Results,
I
I
got
know, I
anything.
know. Oh, okay. Well, I'm sure she's aware that you guys need that feedback, so I'm sure she'll have that marked in due course. And then if you could please feed back to me as well, I'd appreciate that. Okay.
Yeah.
Brilliantos. Right. So let's dive into trig and let's see what you can remember, what you're good at, and what we need to brush up on. Do you want to start off with the first question? So this is here to just prove an identity that sine 2a is equal to 2 sine a cos a. And you've been given a bit of a hint here as to what you could use. Do you want to start off with this one first?
Okay.
Yeah.
You use this, so sine 2a would be like sine a plus a. You could write it
Good.
as.
So I could rewrite sine 2a as sine a plus a. Good.
And then, so that would be sine a plus a is sine a cos a.
Yeah, so this is equal to
Plus
sine a cos a plus.
cos a sine a.
Correct. And they're no different, aren't they? Same thing. Yeah, very good.
Yeah.
So here I've got two lots of sine a cos a. Yeah. Therefore, we can say that sine 2a is an absolute identity of 2 sine a cos a. Excellent. Beautifully started. Okay. What about the second one now?
Okay, so you would start by doing r cos theta plus alpha,
Okay.
standard.
Yeah, I like that. So r cos, I want to start off with this. So what would this be? What would I rewrite this as?
Is it cos theta? I forgot the
Not to
formula.
worry. So the identity.
Okay, cos theta cos alpha.
Yeah. So which identity are you using here? Cos a plus b is cos a.
Cos b.
Yeah.
Minus sine a sine b.
Correct.
So then it would be.
So then it would be r. I'm going to put the r on the outside.
Yeah.
I could use it. Yeah. Is that okay?
Yeah, that's
so
fine.
We've got cos theta plus u minus sine theta and sine alpha. Okay, what should I do next?
I would usually expand it now.
Okay, so if we expand it, that's fine. So I've got r cos theta plus alpha minus r sine theta sine alpha. Good.
If you swap the cos theta and the cos alpha,
If I swap the cos theta and the cos alpha, so if I write this as r cos alpha and cos theta minus,
and do the same, yeah.
do the same,
So that
sine
means
theta. Good.
r cos theta would be equal to 2.
Are we sure it's r cos theta?
Well, you could rearrange it to get cos theta is equal to 2 over r. And then drop.
Yeah, but if I'm equating it to this thing here, which says 2 cos theta minus 5 sine theta, take your time. What should I equate? You're nearly there, but you just mentioned something incorrect in terms of what should be equated.
As in the 2 would be the cos alpha. I mean alpha, not theta.
Thank you.
Thank
you.
I'm saying the wrong thing. R cos
Yeah,
alpha.
that's fine. That's the reason why I kind of thought. I think she knows what she's saying. It's just, you know, when the mind knows what it means, but the mouth just says something else.
Yeah.
One of them. Okay, there we go.
Sorry.
So we're saying this. Yeah, you're absolutely right. Yeah, and then of course here this will be mapped to this here. Yeah, absolutely spot on. No problems. They're excellent. So what would you then do?
So then you would, so if r cos theta is 2, you'd get cos, I mean alpha. I keep saying theta.
That's
Sorry.
okay.
Cos alpha is 2 over r.
So cos alpha is 2 over r. Okay.
I would draw a triangle now.
Okay, at this point you draw a triangle. Okay. So tell me what
So
you
then
do in your triangle now. Put an
adjacent
alpha
would
in
be
there.
2. Yeah.
Okay, and then what would you say?
The adjacent side is 2, and then the
So
hypotenuse
the adjacent
is
side is 2, and the hypotenuse is r.
yeah. And then if you're looking at the sine alpha one,
Yeah.
it's 5 over r, so the opposite is 5.
Okay. So it would be, so this side would be 5. Is that right? 5
Yeah.
over r, because as you said, sine alpha would be given by 5 over r. Okay, what next?
And then you use Pythagoras to find
Good,
r.
good. So what's r going to be?
So it's 4 rad 25 square root 29.
Square root 29, very good. So r is, so it says where r is in the form of root k, where k is an integer. Okay, so there we go. So this here is r, we found r, where k is an integer.
Yeah.
And give alpha, it says, give alpha correct to 3 significant figures. 3 sig figures. So what is alpha then?
So you could sub r back in to either one of sine alpha or cos alpha.
Yeah. So what's that going to give you then as your final value for alpha? You're absolutely right. 5 over root 29.
I'm in radians, hold on.
Yeah, I would stay in radians.
Would you? Oh, well, yeah, because
okay. Here it says that alpha is between 0 and pi over 2.
Okay.
And these are radians.
1.19.
There we go. So alpha is approximately equal to 1.1923 SF. Okay, and this has to be in radians because range is in radians. That was beautifully done. Well done. Excellent stuff. All right. And these normally carry quite a few marks, so it's good to be able to bag these. Normally, you're talking no less than 4 marks generally, but you can go all the way up to 6 or 7 marks just with these kind of questions. Okay, excellent. Okay, something of another proof as well. Now this here will require you to put pen to paper and use some of the identities.
Do you have to do the addition formula?
Yeah, so you've got I mean, here, yeah, but remember that when you look at those identities, they're normally represented for both the condition where you're either adding the angles or you're subtracting the angles. Yeah, so what I mean is just
they've got different signs, you mean? Like when you expand.
yeah,
like the
so
formula.
yeah, the sign changes for the cosine, not so much so if I've got, for example, here sine A plus or minus B, if I expand this simply just becomes sine A cos. Now we're going to take the cosine of this here, so cosine B plus or minus, yes. And what am I going to have this sign? Sine of B and cosine of A. So the sign simply follows whatever I have in my brackets. However, for the cosine, so cosine A, plus minus B, what does this expand to? Well, this is cosine A, cosine B. Now at the top, it's minus and plus at the bottom. So if these were added, A plus B, you need to minus them. If they were minus, you need to add them. Is that making sense so far? And then over here, you'd have your sine A and sine B. So this is a condensed version of the double angle identities.
Yeah. So you'd use them in the
Correct.
So for the sine A plus B is sine A cos B.
Sine A
plus
cos B. Next term.
Add.
Good.
Sine B cos A.
Yeah.
And then it'll be all of that added
Yeah.
to sine A cos B minus sine B cos A.
Yeah.
And then over cos A cos B minus
Good.
sine A sine B.
Good.
And then that add cos A cos B plus sine A sine B.
Good. What next?
Could you cancel things out?
Yeah, this is now when we start looking at what can we cancel out.
You've got cos A. Oh wait. Sine A. Can't. You've got. Could you like?
You're on the right track. It's just trying to spot. So I know maybe it's the way things have been written here, but this is sine B. In other words, this here is minus cos A sine B. This thing here.
Yeah.
Minus cos A sine B. Here I've got a plus cos A sine B. So these need to what? Disappear.
Yeah, and then the sine A cos B would be 2 sine A cos
Correct.
B.
Good. So at the top, that will be 2 sine A cos B. Good. Keep going.
You've got 2 cos A cos B at the bottom.
Yeah, correct. So these have to say bye-bye. Do they?
No.
Thank you. Not these ones. You mean these ones here?
Yeah, those ones.
Correct. I agree. Oops. Just waiting for the eraser to come through here. Ooh. I'm going to rub off everything. Okay. Anyway. Okay. And we'll say it's these ones going disappearing. So now you've got, oops, cos B. So what do you have here now? we have
2 cos A cos B.
2 cos A, oops, cos B. Good. Next step.
The cos B's can cancel out and the 2's.
Spot on. And now
So
sine A
it's
over
just-
cos A.
It's tan A.
Absolutely. Spot on. Good. And good use of the double angle identities. Excellent. Right. Something a little bit on a slightly different side now. How would you do this one?
You know, cot 2A, I mean, cot can be written as 1 over tan.
Okay, good. So we know here that cot of theta is the same as 1 over tan theta. Okay, what should I do
you
next?
have to use the formula for tan 2 theta?
Correct.
That'll be 1 over 1 minus 2 tan squared theta. Wait,
You're nearly there.
2 squared theta.
Tan 2 theta.
1 over
Not quite.
tan theta.
It's
over-
2 tan theta.
Oh yeah, 2 tan theta over 1 minus
Good.
2 tan. Oh wait, tan
No.
squared theta.
1 minus tan squared theta.
Yeah, oops.
Okay.
I'll
No
have to
problem.
learn. Anyway.
There we go. It's been a long week. I perfectly understand. Okay.
So if you're doing
Are
1
there any
over
other? Are there any others that you know of?
cos 2 theta.
Cos 2 theta?
1
Might that be
minus 2
useful?
sine. No.
No,
Probably
not
not.
in this case. But what might be useful? Any others that may be useful? So we've got the tan one. Would it help to know anyone with a sec squared?
Sec is 1 over cos, isn't it?
Mm-hmm.
For sec, oh, it's the 1 plus wait. Oh, 1 plus tan theta. Tan square. Wait. 1
So take your
plus
time. I
tan
know
theta
exactly where you're
sec
starting
squared.
from. You're starting from sine squared theta plus cos squared theta is the same as 1. Yeah?
Yeah.
You happy with that?
Yeah.
Now, if I divide everything by cosine or cos squared theta,
Get tan squared theta
so I get tan squared theta plus 1 is equal to
sec squared theta.
sec squared theta. So I've got another one for sec squared. It might or might not be useful. But just because I've seen a sec squared, it's nice to think, do I have everything, all the tools I need?
You could probably, you'll probably end up getting the tan squared theta plus 1 on the left-hand side. Maybe.
Maybe, yeah. Maybe, absolutely, maybe. So what would we do then? How do we progress from here?
Well, what we said before.
So what do you want me to do? You want me to write this as 2? Sorry, let's use a black pen. So 2 minus 2. Well, this is cot 2a. So that's the same as
What you'd do the
1 over
yeah.
1 over tan 2a. Is that right?
Yeah.
Yeah. Is that what you want me to do? Followed by tan a. Well, have a go at doing it on a paper, and then you can give me instructions as you, because it's definitely one of them where. Sorry.
Because you know when I said the identity for tan 2 theta.
This one here, yeah.
Yeah, I was gonna flip it and then just put it in.
Okay, so you're gonna get this one here now. Okay, that's fine. Okay, that's what you want to do. So if I now do 2 minus 2, and then this is 1 over tan 2a is going to be what identity? So 2 tan a over 1 minus tan squared a. What does this simplify to, this part?
is it just
And of course, there's a tan A on the outside.
tan A on the outside?
Yeah, because so this part here, just to follow, that's this 2 is that 2. That 2 is this 2. And then I've done a representation of cot 2A, which is here. And then I've also got a representation of tan A. This tan A here is this here, which is also that there. So then
you know what I would have done in an exam? I meant, you know, when you plugged it in, I meant if you flip the tan 2 theta equation, isn't that basically like the reciprocal? So
I see what you're saying. So what you're telling me here, okay, I think I get what you're saying. You're saying you'd have done it right away and said 1 minus tan squared A over 2 tan A, like so.
Yeah, that's probably what I would have done. I don't know.
Yeah, no, but you're right, because 1 divided by this thing gives you that.
Oh, okay.
Yeah.
Yeah.
Because what this is it's saying 1 divided by 2 tan A over 1 minus tan squared A. So of course it's a division sign, 1 divided by this. So this means that you flip this and you flip these around. Flip the fraction over to tan 2A or tan 2A. Yeah, so you're absolutely right. You're absolutely right. So 1 minus, good. What can I do now? So I'm now here. What should the next thing to do be?
Could you cancel it out? Or do you have to expand? That you've got a tan A, right?
Yeah, so I can cancel them out, can't I?
Yeah, and then you could, well, you'll have to expand. Wait, the -2 times and the bracket, maybe.
Yeah, so what should I do with this 2 here?
That 2 would be cancelled out, minus
Correct. This would
1.
leave me a -1 there. So in other words, this simplifies to 2 minus 1 minus tan squared A. Next.
I would probably expand the bracket.
Yeah, I like that
You
move.
get 2.
So you get 2 minus 1 plus tan squared A.
Yeah, and then you've got 2 minus 1, which is 1.
Good.
Plus tan squared A, which is also equal. So that's equal to sec squared.
Correct.
A.
Which is equal to sec squared A. Excellent. Good. Well done. Very good. All right. Super duper. Okay. Now, number 5. Now that we've done the double, show that tan to state clearly any trigonometric. We've already used something like this, so I can leave this one here as a bit of a homework problem. Now, no numbers given for number 6. So this one carries a little bit more marks than what we've done previously. So can you have a go and let me know what your final answers are? So have a go at doing this on a piece of paper and let me know what your final answers are for alpha and R.
Is it like for I?
So you found, sorry?
For I just, does it, when it says is to be written in the form R sine theta
Yeah,
plus
so
alpha?
this here now is very similar to what we had done, but this time you're using a sign identity, aren't you? Just to remind you, we've done a very similar problem, only this time around. Can you see this says is to be written in the form R cos. Are you happy? So the steps we took here.
So you need to find R and then, right?
Absolutely, but just be mindful that what you've been told to do here is to write it in the form R sine.
Okay.
Are you following that?
Yeah.
Good.
Okay, for the first one.
Yeah.
For R, you know when
Sorry,
it says
are you finding part 2? Sorry.
for I.
Or I, yes.
Wait. I think. Okay, is alpha just the sine inverse of B over R? I don't know what it means by
B over R.
yeah.
Not quite. So you want an expression alpha that will be written in terms of A and B. So no R included in there. Likewise, your expression for R should also be written in terms of A and B. That makes sense.
Yeah.
So tell me what you've done. Did you take the same approach and expand this?
Yeah.
Very good. That's the first
I
step.
expanded it and then flipped it. Did the same as before.
What did you write this as then when you expanded it?
R sine theta cos alpha.
R sine theta cos alpha. Oops, that's a rubbish cos alpha. Cos alpha.
Plus,
yes, plus
R cos theta sine alpha.
R cos theta sine alpha. Very good.
Yeah, at this
And
point,
then what did you do next? So you wrote it in terms of, did you rewrite it?
Yeah, rewrite.
So R cos alpha sine theta.
Yeah.
Yeah. And for this one, then you rewrote it as R sine alpha cos theta.
And then the R cos alpha is A and R sine alpha is B.
Yeah. And sorry, they want them in terms of alpha and B. Sorry, right alpha, sorry. So bad what they've used here in terms of A and B. So this is the letter A. And this is alpha. Okay. So there we go. Good. So you said that R cos alpha, because now you're matching it up to this expression, isn't it? A sine theta plus B cos theta. Yeah. So R cos alpha is A, and R sine alpha is B. We're happy with that?
Yeah.
What can you do next now?
Don't you need to find what alpha, I mean, expression for alpha?
Yeah, so what can I
Usually
do?
to find alpha, you would, like if in the other example, to find alpha, you would have done the inverse, right?
Yes,
Like
correct.
Of like cos A over R, whatever that would be.
So if we call these two equations.
Okay, yeah.
What happens if you do equation 2 divided by equation 1?
You get tan alpha.
Very good.
Is B over A.
Good. Therefore, what is alpha?
Inverse of tan B over A.
Correct.
Oh.
Good. Now part 2.
Do you use the answer to part I? Do you have to?
You can, absolutely can. Because now you know the relationship here. And you also know these relationships.
Yeah. Is it like the triangle thing?
Yeah.
So then you'd have, is it like A squared plus B squared is like R?
Nearly there. Now for this one, of course, you can use the trig to say the identity cos squared alpha plus sine squared alpha is the same as 1. So if I use that expression, r squared cos squared alpha plus r squared, I'm going to square each of these terms, plus r squared sine squared alpha. Yeah?
Yeah.
What's that going to give me? So this will give me r squared cos squared alpha is the same. This is the same as a squared.
Yeah.
So squared all the terms. R squared.
B squared. I don't know.
Correct. So this here is the same as a squared plus b squared, because this is a squared, that's the b squared term. You happy with that?
Yeah.
I can factorize the r squared out, can't I? This here is equivalent to 1. So you get r squared equals to a squared plus b squared. Therefore, r is equal to square root. So you were so nearly there. You said a squared plus b squared. You just needed to.
I did get actually.
You said a squared plus b squared.
I got the square root a squared plus b squared is r, but I didn't do all of that.
Excellent, excellent. Well done, well done.
All the r squared cos alpha and all that. I did get that. I got the.
You got there, good. And you can get there as well also by using these here. So if you drew your triangle and said this is alpha, well then this would be your opposite. So your adjacent would be A and your hypotenuse would be R. And if you use this expression, sine alpha now, that would be B. So you could also do it that way.
So from there, I think I just did a squared plus b squared is equal to r. So then you'd like r squared, I mean, and then you square root it. That's all I did. I didn't do the.
And this is an easy way of doing it as well. So good.
Do you need to write all the trig things out to get the marks?
No, as long as you draw your triangle and you show this and you do, this is Pythagoras, a squared plus b squared equals r squared, you get the marks.
Okay.
Because you've shown where the relationship and the triangle you're using. But if you don't, then you can, of course, use an identity as we did, show that you're squaring everything, and show that that equals a squared plus b squared. So it's the same number of marks you get. Okay. Good. Yo, well done on that one. That was not an easy one. Tan 2 theta sec theta. Do you want to have a go at this one?
Will it be all right if we could do another one? Because I feel like I could do this one by myself.
No problem. We'll put that as a homework problem. How about this one?
Okay. Is it just you have to find A and B using the formula?
Given that, say, given that alpha is equal to A plus B, find the exact values of sine alpha, cos alpha, and tan alpha. So A is which angle?
The one like there. Yeah.
And B is which angle? That one.
There.
Good. Excellent.
Okay. To find A from that small triangle. Okay. I mean, could you do sine A 4/5?
Yep. Good start.
And then inverse of
so sine A equals, well, it wants the exact value, so I'll be very careful about using a calculator. I'll be very careful.
Just leave it as it is then.
I would leave it as it is. Absolutely spot on.
You could find B.
Yeah.
Which is like sine B 8/10.
Sine B is 8/10. Good.
Is it? Do you have to use like a trig rule?
So
wait,
okay.
Wait, no, probably don't. Okay, so the A plus B.
Yeah.
So the inverse of both of them added together. But you can't. Wait. Could you? I don't know. Could you like draw? Oh, you can't draw a triangle because probably. I don't know what else.
You can, but maybe as a bit of a hint. Are these numbers standing out at you? Are they screaming out at you?
Oh yeah. 4. It's hard when you like times it by 2. 4/5.
Very good.
So it's like twice the.
Hang on. Is it twice?
No, not twice.
Sine A is 4/5. Sine B is 4/5. What's that telling you?
They're the same.
Good. That's a very important conclusion to reach in solving this problem.
Now, what do you do?
Yeah, okay, so good. So now we know. So we know that, okay, alpha is 2A. Or alpha is equal to 2B. We've eliminated one of their knowns.
Oh.
We know that the two angles are equal.
Okay.
Yeah.
Oh. Yeah.
Therefore, if I'm being asked to find sine of alpha, I'm being asked to find sine of 2a or sine 2b.
Mm-hmm.
Any ideas what I do next?
So you've got sine alpha, sine. You could the sine 2a.
Mm-hmm.
Is that like an identity?
Very good. And what is that equal to as an identity?
Like 2 sine a cos a.
Very good. Excellent. Good. So now I can, what can I do? Well, I know what sine of alpha is. This is 4/5.
Yeah.
Can I work out what cos of a is?
Wait.
So take your time. If you know what this is, you've been given all the dimensions. Can you work out the cosine of that angle?
Oh, I get what you mean.
Mm-hmm.
This is like 3/5.
3/5. Spot on. So this is 2 times 4/5 times 3/5. What's that give us then? 8 times 3 is 24/25. So we found sine alpha.
Yeah.
Now, can you find cos alpha and tan alpha?
So you need to find cos of 2a and tan of 2a.
Cos of 2a, essentially, you're right.
You need an identity, but cos has 3 of them.
Mm-hmm.
You found, wait, the 24 over is, okay, that's sine alpha. Could you do the 2 cos squared?
We possibly could, but we could make our life a little bit easy here. Yeah. So
Oh,
with all
use a
these
sine
things,
one.
it's just trying to think of ways to think of your life. So I'm going to give you a bit of a hint just to stop you going down a wrong path. So if you already know that this is alpha and the sine of this angle we have worked out is 24/25, and the sine is given by the identity opposite over hypotenuse, it means I can make, in my triangle, I can make the opposite 24, and I can make this 25. That's the sine of this angle. So what would the cosine of this angle be now?
Oh, you could, just do Pythagoras.
Correct.
And then find.
Yeah. So in this case, then I'm going to get the square root of what numbers? 25 squared minus 24 squared.
7. I mean, when you square root it at the end.
So I get 7. You're right. So therefore, what is the value of it? In this case, the value of cos alpha.
Oh, it's just 7/25.
Correct.
Oh, I was making it so complicated.
I know, and that's why I realized that you were so caught up in the land of identities that you're.
It's because like you automatically see the cos to it, and you think you need to use like an identity.
You're absolutely right. And it's not an easy question, this one per se. This is actually 7 marks.
Mm.
So there's and the reason for that is because there's so many different routes you may go, some routes which may be longer. So you could, of course, if you wanted to, in this case, you could, of course, use the identity sine squared alpha plus cos squared alpha equals to 1. So you know what sine alpha is, square it. So you would have 24 over 25 squared plus cos squared alpha equals 1. 1 minus that, then find the square root, then you'd have plus or minus, then you have to work to say, okay, well, this is an acute angle, therefore you're going to have to take the positive value. So that would be a much, much longer route, and you have to do a lot of reasoning to make sure you're picking the right values from the square root sign. Whereas this here,
I feel like in that example, if I was in an exam, I would probably like do that.
Probably do the sine squared identity.
Yeah, I would.
Yeah.
That's probably my like way of thinking. That was probably what I would do, but I wouldn't reason it. So I probably won't get marks.
But I'll tell you something though. This using the triangle is such a useful little trick, and it even comes into play in integration, not differentiation. In integration, definitely it comes into play, and a lot of these trigonometric questions which involve finding a sine of 1 and then a cosine again involve just drawing a little triangle. So it can be quite helpful at times once you've found one thing, especially with they ask you find sine alpha, cos alpha, just think, okay, if I've got one, can I find the others from the triangle? Just saves you a little bit of time. Okay, awesome. And so of course, the same thing in this case now, if you want to find the tan of the angle, what would the tan of the angle be in this case?
24 over 7.
24 over 7. 24 over 7. So we're saying tan alpha, oops, 24 over 7. Okay, now let's just ask ourselves then, so this angle here itself, the angle that we're seeing, this is an acute angle, isn't it? Yeah? It's an acute angle, A. So what's the value of A if you just punch that into your calculator? What's the value of A? Just to suss out what A is as a value.
Okay. Wait, hold on. $36.86.
If you do the inverse of it and then you do the, okay, so you get 36. Just 1 moment.
Wait. I think I've 53.1.
Ah, that's more like it. Yeah, I literally just got my calculators going. She's probably still in radians at this point. Okay, so what do you get? 53.1. 53.1. Are we sure? Shift sign answer 53.1. Yeah, I get that as well. So we know that A is equal to 53.1 degrees. Okay. So now twice the value of A, because that's what alpha is. What is twice the value of A? It
would be that times by 2.
Yeah, so 106.2 degrees equals to alpha. Yeah. Now, this is why it's a 7 marker, because there's another layer of then thinking. It's a diabolical question, right? So do you remember that triangle ASTC?
Yeah.
Okay. So as long as the angle is between 0 and 90, the value of its cosine, sine, or tan is positive.
Yeah.
In this quadrant, where 106 would lie, the line 106 degrees would be somewhere there.
Yeah.
Yeah. So in this quadrant, the only trigonometric function that will give a positive value will be what? Will be
sine.
So tan of 106 is a negative. A cosine of 106 is also negative, because unless it's in this quadrant, only then would the cosine be positive. Unless it's in this quadrant, only then will the tan be positive. But if they're in the first quadrant, all trigs will give a positive value. So at this stage now that you've looked at this, found this, now you'd go in and confirm your final answers. So for this one, it's not 7/25, it is, we say, as alpha is in second quadrant, cos alpha is equal to minus 7/25, and tan alpha is equal to minus 24/7. Did you follow that?
Yeah. Okay, so we found all the sine alpha, cos alpha, tan alpha.
And the only thing now that we did was we wanted to find out what the signs should be. Again, should they be positive or should they be negative?
Oh.
And that's why then we found actually what the angle A itself is, and therefore what is angle 2A, to find out where in our unit circle it actually sits.
Oh. Don't you need to find
parabolical? Go on.
How about the sine alpha one? You've got cos alpha, tan alpha.
Yeah, so the sine alpha one, positive. The reason why we didn't change it is because the value of alpha we have established is 106 degrees. And remember, we always measure anti-clockwise. So 106 degrees means you go past the 90-degree angle.
Yeah. And
16, a little bit over 16 in this direction. So that's where the angle would sit. So remember, I don't know if you were taught this, but the way to remember is we say all science teachers care. So if the angle is in the first quadrant, if you take the tan, sine or cosine of it, it's always a positive number, the answer. Yeah. If the angle is between 90 and 180 degrees, only sine will give you a positive sign of that angle. And this is positive, 24/25. Yeah. All others will give negative results. So when I found tan as 24/7 and we found cosine as 7/25, the final step we did is to check to say, would this be positive or negative? Yeah. So remember, the cosine of 53.1 is 7/25. That's the cosine of 53.1. The cosine of 106.2 is minus 7/25 because it's in this quadrant. Yeah. You following that so far? Good. So very, very challenging question, this. Really challenging for 7 marks because there's so many other steps and so many other links that you then have to make. Yeah. But I'm hoping that it's given you some much needed tools, you know, just to get to discuss and see how to think around a problem like this. Is that okay?
Yeah, that's okay.
Good. Excellent. Okay, what do we have here? Number 9. I can let you have a go at this one as a homework problem. Okay, number 10, show that root 2 cos theta plus pi/4 over sine theta minus pi over 2 is identical to tan theta minus 1.
Would you use the identities? I mean, the addition formula.
Yeah, in this case, you will need to do that, but there might be a few things you need to do in addition to that. But you're absolutely right. You would be thinking of employing cos A plus B.
Yeah.
And also sine A minus B.
Would you be, after you do that, would you like cancel things out?
Precisely so. And then you'd also have to think on simplifying what the actual terms would be. So for example, if you expand this, of course, we know it's going to be cos A, cos B, minus sine A, sine B. So in this case, your root 2 would be on the outside. So you'd have cosine of theta and cosine of pi over 4 minus sine of theta multiplied by sine pi over 4. So you'd actually have to evaluate what these are. But these are standard. Pi over 4 is the same as what?
Isn't it 90 over 4?
Not quite. So if we wanted to find the cosine of pi over 4, what's that representing? So pi over 2 is 90 degrees. What is pi over 4?
45.
Correct. So what's the cosine of 45? What's the sine of 45?
Cosine of 45 is not there.
It should be there. So make sure you memorize this. Root 2 over 2.
Oh, our teacher said we don't have to.
That's strange. I've always, I suppose it's the calculators you're using. I always advise my students to memorize these because in the exam, you just have that more, you're much more slicker because you're not having to constantly go to your calculator. So at GCSE, it's an absolute must. Students are made to memorize some common angles. So we've got to know what the common angles are: 30, 45, 60, 90, 180. These are the main ones, because after this thing, normally it repeats itself. Okay, so 30, 45, 60. Sorry?
She went through it, but then she was like, you don't need to remember it. You can just use your calculator.
Okay, well, there we go. That's another way of doing it. That's another way of doing it. But, of course, I understand if you are in a rush and you don't feel there's enough time for you to memorize these, you'd rather be focusing on memorizing other things, then that's absolutely allowable. That's understandable. But if we had the luxury of time, I definitely would have said, I strongly urge you, they just make it more slicker.
You know, when you put in the cos root 45 into your calculator.
Yeah.
It doesn't work.
You're joking. So you just put cos of 45.
Oh. I was doing the inverse.
Okay. You've had a long day, Ray. I know, we all have. Okay. Right then, Ray. It's been really, really good. The way you were articulating yourself, and even when we encountered problems, you were trying to think of other ways around it. So that's really good. You need all those traits, really. And I'm glad to see that even in the most novel of problems that were quite challenging, you approach it with the right spirit. Okay, excellent stuff. So what I'll do is, yes, for our next lesson, we have another session scheduled tomorrow, isn't it?
Yeah.
Yeah. What would you like your main focus to be for that lesson tomorrow?
I'll do a past paper before then, and I'll probably ask you questions on it.
That's fine. So you're going to do past paper questions. Okay, So like I say, if you want to WhatsApp me some of the questions beforehand, I can put them onto the screen. That would be really great. Much easier than to talk about a problem if I've got it on the board. But I like to do that in advance time. So then I'm not rushing 10 minutes before I have a lesson trying to put things on the board. Is that okay?
Yeah, that's fine.
Yeah. So yeah, we've already decided on time. So past paper questions and let me know. Now, I know we haven't done mechanics in a while. We've focused on pure a lot. So if you do fancy going through some mechanics, I think that would be a good idea, just so you keep everything balanced, okay?
I was thinking doing pure revising this week, mechanics next week.
That's fine. So pure this week. That's fine, Rare. That's absolutely fine.
Okay.
Okay, super stuff. Righty. I'll send you this. I'll also send you the answers to the homework questions, so then you can, of course, have a go at them in your own time. And if you get stuck, you can always look at the worked or model solutions. Is that all right?
Yeah, that's fine.
Excellent. Super duper. I look forward to seeing you tomorrow. Have a lovely Friday evening. And well done.
Are we seeing each other on tomorrow or Sunday?
Yeah, hang on. I was fairly sure I mentioned, I've put this on my diary. I do apologize. Let's have a look here. 5 p.m. Sunday.
Yeah.
So that gives you enough time then, doesn't it?
Yeah.
To go through past paper questions, and then you can get in touch with me in the evening or something once you've had a good go at the questions. Okay, so 5 p.m. Sunday.
Okay.
Super duper. Thank you for reminding me as well. Yeah, that it's on Sunday. I shall see you on Sunday at 5 p.m. Have a lovely, lovely grand evening. And I can tell that you could do with some rest as well. So be nice to yourself, okay?
Yeah, okay.
All right.
Thank you.
Speak soon and see you soon. Cheers, then.
Yeah.
Bye.
Bye.
Bye. Bye.